Analysis is actually an incredibly powerful tool that as a chemistry student you are going to want to learn. So dimensional analysis is essentially a way for someone to convert units of one value and their number into units of another type. And so we use things called conversion factors in order to help us do these conversions. I've listed here several kind of common conversion factors that you might use in chemistry. You might use more in this particular class, Chemistry 1, with things like length, maybe changes in mass, volume, and you might use pressure towards the end of the semester. We might use a little bit of energy kind of in the middle of the semester. And we don't really use conversion factors for changing temperature. Those are actually a set of formulas in which you plug in one value for that particular unit and then you'll solve for the unknown. But what I'm going to do today is I'm going to show you guys how to convert from, say, one unit to another unit using this methodology called dimensional analysis. So I'm going to give you a couple of examples. Here's one. Here's an example where I want to convert an amount in inches, this 535 inches, into an amount in miles. So we don't know how many miles this is. First off, before we do this, let's determine our unit path in which we know conversion factors for inches to miles. There's a common conversion factor of inches to feet, and then there's a common conversion factor of feet to miles. And so the conversion factors for inches to feet is 12 inches equals 1 foot. And we will use them in the form of fractions. So how you use this fraction depends on what unit you're going from or to. So either fraction is perfectly acceptable. We will just choose one given our particular situation. And then for feet to miles, we have a conversion factor of 5,280 feet to 1 mile. And again, we'll use these in fraction form. So how to do this? We're going to start with 535 inches. And we're going to put this in fraction form, and we're just going to put it over 1. We're going to then add our conversion factor in fraction form and multiply this times our beginning value. And how do we choose? We're going to choose either the first fraction or the second fraction. And how we determine which one we're going to use is based on what's the unit in the numerator of our starting number. We want that value in unit to go in the denominator of our fraction. So we pick one. It turns out it's this one right here. So we will write that fraction here, 12 inches. And it turns out if we actually multiplied these two fractions together, inches would cancel themselves out. And so that's the whole goal, is we want to cancel those units out and be left with the unit of feet. So we now have used our first conversion factor. Now let's move to our second. With the second one, we're going to again use these in the form of fractions, and we want to now use what is the unit in the numerator of our previous fraction and put that in the denominator. And it turns out that's our second fraction here. So we will put the values of 1 mile and 5,280 feet, and our feet will cancel out, and this leaves us the unit of miles, which is what we were trying to get to. When we do our math for this, in our calculators, I get a fairly long decimal number that ends up being this guy right here, 0.00844,381. Now what we want to do is make sure that in our calculation of conversions, the units, the number of significant figures in our initial number needs to be represented in our final number. Typically, conversion factors, depending on which ones you're using, these are exact values. So exact values we don't use in significant figure calculations. So this particular one is an exact value, and we're going to use this one as an exact value also. So we don't actually use the numbers that happen to be in these fractions for that. So we look at the 535, and it turns out there's 3 sig figs in that, so we need to have 3 sig figs and our ending number. And so what we'll do is we'll use our 3 to round up our 4, which it won't, it'll stay there. So our actually ending value will be 0.00844 miles. And that is how you do dimensional analysis. So I'm going to do a few more examples. If you want to follow along with these examples, that'd be great. And they're a little bit more complicated examples. So this one is an example where we're going to convert feet into centimeters. And the problem states Marie Curie stood 5.0 feet tall. How tall was she in centimeters? So again, we're going to look at our unit path, and we're going to go from feet to inches, and then inches to centimeters. The unit conversion for feet is 1 foot to 12 inches. We'll have our 2 fraction possibilities. And for our inches to centimeters, it's 1 inch to 2.54 centimeters. This is also, again, an exact a conversion factor, even though there are decimals here. The fraction that possibilities are shown. So we'll start with our beginning number. 5.0 feet over 1. We're going to multiply it times our first conversion factor of feet to inches, and we're going to choose the fraction that has feet in the denominator, which is this one right here. So we'll put 12 inches in the numerator, 1 feet in the denominator, and our feet unit will cancel. Now we'll move on to the next, since we've converted from feet to inches, we're going to go from inches to centimeters, and this is where we're going to use inches in the denominator, and so that ends up being our first fraction here. So we'll put 2.54 centimeters over 1 inch, and our inches will cancel, and this will leave us the unit of centimeters. And it turns out when you do this in your calculator, the problem will give you 152.4. But now at this point, we need to look at significant figures. So our beginning number has 2 sig figs. And each one of these conversion factors here are exact. So none of the numbers in these values can be utilized to determine significant figures. So that means this number needs to be put in 2 sig figs. We can use the 1 and the 5, but the 2 will have to round. And it leaves the 5 as is, and we will put a 0 in the 2's place. No decimal. If you put a decimal, that makes the 0 significant and then makes it a 3 sig fig number, but we don't want to do that. And then we're going to make sure that we put our units of centimeters, and that's our answer, 150 centimeters. So let's go to the next one. And this particular problem actually utilizes values and units in multiple locations of the denominator and numerator. So it's not just one unit value. And this problem states that Captain Marvel can fly, according to the MCU Google search, they say that she can fly at the speed of light of 2.99 times 10 to the 8 meters per second in a vacuumous space. So how fast is this in miles per hour? So we're actually really looking at changing the unit of meters to miles in one kind of problem, and then seconds to hours in another part of this problem. So we have basically 2 paths, meters to miles, and the conversion factor of miles to meters I have here as 1 mile to 1,609.34 meters. This is a measured conversion factor, so that means that this value here, its sig figs do count. So this would be 6 sig figs. Conversion factors or fractions are shown below. That, and then the second to hour conversion factor is 3,600 seconds to 1 hour. This is exact. Okay, so we're going to start with our beginning number of 2.99 times 10 to the 8th meters, and that's per second. And we can just put a 1 here in the second for that unit. So what we're going to do is we're going to convert the numerator first. So let's do that. Let's convert the numerator from meters to miles. And so that means we're going to use this conversion factor here with the meters on the denominator of 1,609.34 meters to 1 mile. When we do that multiplication, you can cancel out the meters. Right now, if we were to stop, the unit for this particular value would be in miles per second. So, but we don't want to stop. With seconds as the denominator, we want to convert that to hours. So it turns out you can just continue adding on fractions of conversion factors, just working on the second part. So we're going to convert seconds into hours, and it turns out we're going to put seconds as the numerator, and so we're going to use this first fraction here. So 3,600 seconds to 1 hour. Make that a little bit better. And our seconds will cancel, and it turns out right now we're in the units of miles per hour, and that will finish us out for getting to the correct unit. You do all of the multiplication and division of this particular problem will give you an answer of the following. So this is, in the way that you'll do this mathematically on the calculator is do the 2.99 times 10 to the 8th and multiply that times the 3,600 seconds, and then go through and divide by any denominator in that value. So it'll be divided by 1,609.34, and this gives you a value, and I got actually a fairly long number on my calculator of 668.845,614, and there's some decimals to that, so forth and so on. But what we're going to do is we're actually going to take that number and round it to a value that's a little bit more appropriate. So we know that our starting number has 3 sig figs, and that this number in our conversion factor has 6 sig figs, and this guy is exact. So we don't use any of the numbers in this particular fraction to doing our sig fig determinations. So since we're doing multiplication and division, we're going to go with the lowest one. That means 3. So we're going to 1, 2, 3. Everything beyond that then gets used to round this previous number. So that's 669, and then it's 0, 0, 0, 0, 0, 0, and then that will be miles per hour. Now, if you want to put this number in scientific notation, kind of like the speed of light was initially, you can do that. It's whatever your preference is. I will accept either one. So these are 3 examples for how to go through the process of dimensional analysis. I recommend you try some on your own. Bring any questions to class, and I will see you later.